Well, my father thought I should be a lawyer. And I said to him, "What makes you think I would be a good lawyer?" To which he said, "Every time we have a discussion, you turn it into an argument." But I told him that I preferred to do engineering. And he said, "Well, okay, it's your life. Just go with it." The objective was to complete my bachelor's degree. So, of course, the evacuation was a big stumbling block. I wasn't terribly sure what would happen. There was a professor, a young professor of mechanical engineering, Milo Myram Bolstad. And he said to me, "I think you should go for a master's degree, and if you want to do it, I'll arrange for you to get a job at Minnesota." So he had me appointed an instructor in electrical engineering, so I could earn my way toward a master's degree. So that's what I did. And when I got to Minnesota, they were exceedingly friendly. And that experience gave me the courage to go for a doctorate. But an issue came up to put a radar detection line in the far north landmass from Alaska across northern Canada to Greenland. And the issue there was that it was very difficult to supply the northern, frozen northern regions. And so there was tremendous pressure to have a radar station with only 10 people in it, whereas the normal complement was like 250. So we decided that there had to be a different way to detect radar signals. Because I had been working for my doctoral research, trying to perfect an electron microscope, Lincoln Laboratory hired me to work on video displays, and it had to do with detecting radar signals that indicated that there was an aircraft in the air. So we built an electronic backup to detect radar signals. Then the next question was, how good was it? There was a backup, we said it would be less effective, but let's do it anyway. And after we did it, we started to determine how good it was. It turned out to be just as good as the human ear and just as good as the human eye. So the probability of detection curves came out exactly the same. So in effect, we invented the first analog radar signal detection equipment. So that was fun. And you might say, based on that, the director thrust me into that U-2 spy plane business to reduce the radar cross-section. And we did some terrific research, and you might say, kind of laid the foundations for what is called stealth technology. I made a bunch of recommendations of, next time you try this, don't build the airplane first. What you should do is build something that can't be seen by radar, it's difficult, and then see if you can fly it. And the B-2 bomber and the F-117 fighter bomber have characteristics that I recommended after finishing the U-2 program. He took me to Washington to run the spy satellite organization. And the curious thing about it was that the U.S. government did not admit that such an organization existed. But we had a huge budget. We were putting up satellites and spying on all kinds of things. So Even the things that are happening today, the intelligence apparatus in the United States relies on a lot of the things we did back in the late 60s and early 70s. He remarked that it was remarkable that I had gone from a distrusted American to one of the most trusted Americans there is. Mm-hmm. And he added, only in America could such a thing ever happen.
Okay, it's my honor to start the names. First, Fumio Robert Naka.
In their memory, in addition, I'd like to accept this degree today. To restore justice amongst the groves of academia. I hope that this ceremony and gesture today will continue. Thank you.